Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 8D. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2025, Pune, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Pune, India, and the virtual event is being held through Zoom today and the physical event was held day before yesterday in Pune, India, and the virtual event is being held through Zoom yesterday and today, that is on 30th and 31st of January 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentations and 2 minutes for question and answers. On 7 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Amit Thakur. Dr. Amit Thakur is working as a professor and head in the Department of Computer Science and Engineering in the Faculty of Engineering and Technology, Charosat University, Changa, Gujarat, India. He has published 3 books in the area of data mining. He has also served as a member of the technical committee at various national and international journals and conferences. His current research interests include machine learning, deep learning, and embedded deep learning. Thank you so much for joining us for this session, sir. I'd now like to invite Dr. Amit Thakur to share a few words of encouragement with our attendees as we begin this session.
Thank you, Priyanshi, for the introduction. Yes, I wanted to share a few words. In the era of generative AI, it's very difficult to now justify the novelty of research. So I request all the participants to just share their knowledge and make sure that by these presentations, by this research, will really contribute to the society and will do something for the well-being of human beings. So keep your presentation precise and make sure that you try to focus on your contributions and where you want to contribute, where you have contributed in the era of this generative AI and how effectively we can use these AI tools and techniques for the betterment of lives. That's all from my side. We can begin with the session now.
Thank you so much, sir. Now, without further ado, let's start with the session for today. Coming first, I would like to invite Kajal Joseph to kindly present her paper titled A Comparative Analysis of Machine Learning Models. Do we have you here with us, Kajal?
Yes, ma'am.
Sure. I'll just stop presenting.
I'll share my screen.
Yes, please.
It's visible?
Yes, your screen is visible. You may start.
Thank you. Thank you, Priyanshi. Myself, Kajal Joseph. I'm a research scholar in Amity University, Panvel, that is in Mumbai. And my research topic is a comparative analysis of machine learning models. So these are the contents of my presentation. That is, I'll be going through introduction, literature review, then contribution, methodology, results, and conclusion and references. So introducing my topic, nowadays companies have to predict like before, we have seen this Shark Tank India serials. So whether the company will be successful in industry or it will not be successful, that I'm determining through my research. So predicting companies' performance is crucial for investors and stakeholders. Traditional method struggles with handling the complex data and large volume of data. So here I'm using the machine learning techniques for enhancing the accuracy in forecasting the success of the business. So the key models that are used are logistic regression, decision tree, SVM, XGBoost, random forest, and GVM techniques. So here in this particular research, I'm comparing the results that are produced by different machine learning algorithms, and I'm producing the results that which algorithm is giving me the best and possible answers. So the insights of my results will support the business analytics in making their decisions wisely. So in the literature survey, I have gone through a few papers. So here I'm presenting a few papers from that. So the general trends in machine learning based on predictive analysis. This paper talks about how predictive analysis using machine learning has gained the attention of the industries, focusing on the advancements in model performance, like which models are performing better. And the second paper that I have referred is comparative study of ML models for company status prediction. In this paper, it compares the different ML models like random forest, XGBoost algorithm, highlighting the effectiveness of ensemble techniques in improving the prediction of the accuracy. And the third paper that I referred is review of predictive ML models in business. This paper presents an overview of predicting ML models in identifying the strengths and weaknesses of various approaches in business applications. And these are few more papers that I have studied for my research. ML for predictive maintenance and financial forecasting. This paper illustrates how predictive maintenance models can be useful for financial forecasting, drawing the parallels in data requirements and robustness. Big data and predictive analysis in small to medium scale enterprises. This paper explores the role of big data, machine learning in SMEs, empowering the importance of predictive analysis for decision making in their resource utilization environment. Significance of advanced in ML models in business context. This paper affirms the value of ensemble models for company status prediction, emphasizing their role in accurate business forecasting. So this was my literature review. The contribution is I have the data set that I have used is data set is taken from the Kaggle Crunchbase data set. And I have done the multiple, first is I have refined that particular data set and removed the outliers, incomplete data set, missing values and all. After doing the pre-analysis, I've done the comparative analysis using the machine learning techniques. So my findings are XGBoost algorithm and random forest algorithm. These are the two algorithms which gave me the top performance models, and that validates the power of ensemble techniques in predictive analysis. The impact of this is insights for business intelligence and real world applications, the foundations for future research in diverse industries. So the data set, my Crunchbase data set source was having these many files: acquisition.csv, IPOs, information about the IPOs, information about the people that are working in that particular industry, the degrees, the qualification of the CEOs, qualification of the employees. That was the data set content. Then the offices, where are those offices located, milestones, whether they have achieved the milestones or not, the different investments that the company has done, then the funds, then funding rounds, how many funding rounds that the company has gone through, then the objects of that particular company, and then relationships. So these are the multiple CSV files that are available with me from the data set. So I have done the pre-processing, cleaned the data and removed the duplicate data, irrelevant information, and done the predictive analysis, descriptive analysis, data visualization, and I have also done the correlation analysis and visualize the data and interpret the data. So these are my findings. So this particular graph is showing the category versus funding total in USD and funding rounds. So here we can clearly see that the software companies has got the highest funding rounds and the highest funding total. And also this thing, biotech industry is also booming. Biotech industry has got so many funding rounds, and funding total is highest for the biotech and software industry. Next is the inline, it is web industry, and then mobile industry. Then in this particular slide, we can see the analysis of category versus count of status. So the different category and the status of the company, how successful these companies are. Again, here we can see the software companies are having the highest highest operational, and then next category is the web category and others. This graph is showing the category versus the number of products and funding total in USD. So here, number of products in software company are the highest among the other categories like manufacturing, e-commerce, education, consuming, clean tech, automobile, advertising, etc. So this is the descriptive analysis. The total funding received is $412 billion. Average funding received is $2.12 million. And total investment rounds is 6146. Total acquisitions are 9518. And total raised amount is $2539 billion. So this is the final document, final sheet that I have got. Operation among the available data from the data
This is a
set.
7 minutes reminder.
Yes, ma'am. Operational are 93.3 companies are operational. Acquired are 4.78, roughly 5%. Closed companies are 1.3, and the companies which went for IPO are 0.577. So this is the quantitative analysis that is done. You can see Random Forest has given the results of 0.9368, and similarly XGBoost has given the highest. And last is the ensemble model accuracy. By combining two models, XGBoost and Random Forest will give me 0.9370 accuracy. So in conclusion, I wanted to say a detailed analysis was conducted using various machine learning algorithms, and XGBoost and Random Forest were identified as the most accurate and effective models. And the study emphasizes the importance of selecting the suitable model for a specific task. It highlights the power of ensemble methods in handling the complex data patterns. Insights from research offers the guidance for the future applications in company status prediction and other fields requiring precise analytics. The research provides a robust framework for extending predictive methodologies across different domains. So these are the references. Thank you all.
Thank you, Kajal. Are there any
Thank you.
questions? Are there any questions?
Kajal, can you tell me the parameter which can be further optimized to improve the performance of XGBoost algorithm?
Boost parameter.
Which parameter can be optimized to further improve the performance of XGBoost algorithm?
Sir, I have to see that.
Fine, Nish. Can you know any other methods other than accuracy which can be used to measure the performance of these algorithms? Apart from accuracy, any other method do you know?
No, sir.
Okay. Thank you.
Okay. Thank you, sir.
Thank you, Kajal. Moving forward,
Thank you.
I would like to invite Tony Benoy to kindly present his paper titled A Highly Secure Video Steganography Method Utilizing FRT and ECC Charger 20 based encryption. Do we have you here with us?
Yes.
Great. I'll stop sharing so that you can present.
Okay, sure. Yeah.
Yes, your screen is visible.
Okay. So good morning, everyone. I am Tony Vinay, Assistant Professor at St. Kitts College of Engineering, and I am here to present our research titled A High Secure Video Steganography Method Utilizing FRT and ECC Cha-Cha 20 based encryption. And this work focuses on video steganography, which is the process of hiding sensitive information within video files. And our approach here combines fast radial transform, that is FRT, for efficient data analysis with a hybrid encryption model, ECC Cha-Cha 20, to ensure robust security. And this research is a collaborative effort among experts from Jain University, St. Joseph's College of Engineering and Technology, and St. Kitts College. Without further ado, let's start. the session. So this is the outline. It starts with the abstract, then introduction, proposed method, experimental setup, and finally conclusion. So coming into the abstract, here we propose a novel video steganography method combining finite Dirichlet transform FRT and ECC CHA-20 based encryption to conceal secret data. And here keyframes are selected using scene change detection, then decomposed using FRT to extract subbands and orientations. And before embedding, the secret data is encrypted using ECC CHA-20 for enhanced security. The encryption data is embedded into these keyframes, and the original coefficients embedding data and orientations are used to reconstruct the stego video. And the experimental results demonstrate high security and video quality, achieving a PSNR value between 70 decibel and 72 decibel, and an embedding capacity of 72% and an SSIM of 0.9890. So coming to the introduction, the rapid advancement in technology and internet connectivity has brought significant challenges in privacy, cybersecurity, and data protection. Steganography has emerged as a crucial technique to conceal information within digital media, ensuring convert communication and enhance security. Video steganography in particular video steganography in particular is effective due to large hiding space provided by videos, allowing embedding information to remain imperceptible. So common techniques include LSB, DCT, and DWT, each offering varying security level. And here our proposed method leverages FRT combined with ECC CHA-20 encryption to achieve robust security by embedding secret data in the transform domain, ensuring high quality video and strong data protection. And this is the proposed method. In the proposed method, which integrates FRT and ECC CHA-20 encryption to ensure data confidentiality, and the approach is divided mainly into 4 phases. First is detection of scene changes to identify keyframes for embedding, FRT for decomposing keyframes into subbands and orientations to prepare for embedding, ECC CHA-20 encryption, which pre-process the secret data for enhanced security before embedding, and extraction, that is the reverse process to retrieve the secret data and reconstruct the stego video. So this figure illustrates the architecture layout of the proposed system. The process begins with the input video from which keyframes are extracted using scene change detections. These frames are then processed with FRT to decompose them into subbands, specifically focusing on LL subbands for embedding. Simultaneously, the secret data is encrypted using ECC CHA-20 encryption, enhancing its security. The encrypted data is then embedded into the LL subbands of the video frames, resulting in a stego video that securely conceals the secret information while maintaining high video quality. So these are the phases. The first is detection of scene changes. This is the first step in the proposed method. The video sequences is passed using DCT to enable efficient compression and computation. Scene changes are identified by measuring differences between consecutive frames, and a scene change is detected when there are noticeable variations in color and brightness of a frame compared to the previous one. Next is the FRT. Here we are mainly using FRT to identify the select LL subbands so that we can find a space to embed the secret data. So here keyframes are decomposed using FRT, which combines these DRT and DWT. DRT projects the video frame along various angles to capture global features, while DWT is applied to analyze local variations. From the resulting decompositions, the LL subbands is selected as the embedding position for the secret data, ensuring efficient and secure data embedding. The next is the ECC CHA-20 encryption. It is used in this method, and initially ECC key pair is generated to secure the encryption process. The CHA encryption algorithm is then employed to encrypt the secret data, offering fast and secure symmetric encryption. The CHA-20 key is encrypted using the recipient's public ECC key, ensuring secret key transmission. Both the encrypted CHA-20 key and the encrypted secret data are embedded into the LL subbands of the keyframe. This hybrid approach combines ECC for a asymmetric encryption and CHA-20 for a fast symmetric encryption, ensuring robust security and performance. And finally, we have the extraction phase. Extraction is actually the process of reversing the embedding steps. So here, the step 1 is we use scene change detection to locate the keyframes from the stego video. Secondly, we apply the FRT with the same parameters used during embedding to retrieve the secret data from the LL subbands of the keyframe. And finally, we decrypt the secret data by the first decryption the ChaCha20 key using the ECC private key. Then we use the decrypted ChaCha key 20 to decrypt the hidden secret data. So this slide shows the experimental setups. The evaluation was conducted using 4 confidential images like Pepper, Baboon, Barbara, and cameraman, and 2 different videos. The performance of the system was measured using 3 key metrics. The first one is PSNR to assess the video quality. Second one is SSIM to evaluate the visual similarity. And the final one is embedding capacity to quantify the amount of hidden data. These metrics collectively demonstrate the effectiveness of the proposed system in maintaining video quality while securely embedding data. Continuing the experimental setup. This slide demonstrates the comparative results of the proposed method against traditional methods. For video 1, the proposed method achieves a PSNR of 17.8 decibel, outperforming traditional methods that achieve 60.67 and 54.40 decibel. Additionally, the proposed method achieves an embedding capacity of 71.5, higher than the 61.54 and 59.75 achieved by the existing systems. And for also the video 2, the proposed method achieves a PSNR of 72.1 and an embedding capacity of 70.8. So this slide demonstrates the structural similarity index results of the proposed method. For video 1, the proposed method achieves an SSIM of 0.988, and for video 2, it achieves an SSIM of 0.989. These results demonstrate the superior ability of the proposed method to maintain video quality and visual similarity while embedding data securely. So coming to the conclusion. In conclusion of the proposed method, we introduced a distinct approach for video steganography by combining FRT with ECC ChaCha20 encryption. This method begins with scene change detection to identify keyframes, followed by extracting subbands and orientations using FRT for embedding the secret data. The data is first encrypted using ECC ChaCha20 encryption to ensure high security. And the proposed method achieves an embedding capacity of 72%, a PSNR range between 70 and 72 decibel, and finally an SSIM of 0.98, demonstrating its ability to maintain robust security and high video quality as validated by the experimental results. Thank you.
Thank you, Tony. Are there any questions?
Tony, can you just tell me the paper you cited in the comparison 21 and 20? Have they used the same dataset what you have used?
Yeah, the same dataset I have used. And in the previous papers, what I have done is that rather than using these 2 encryption and embedding method, I have already presented a paper in IEEE RAS 2023 where I was using Shearer transform and quasi-group based encryption. And that was the paper that I was comparing here.
And do you think that these 4 images and 2 videos are sufficient to prove your results? To prove the robustness of your method with just four images and 2 videos, or you want a larger data set in the future?
In the future, I am planning to analyze with more data sets.
Is there any benchmark?
And also the video quality is like I am also trying to go for higher video quality. If there is more computation power available, then I will definitely go for high video quality for some more advanced encryption methods, because here also I am using a resolution of only 720p. So in future, I am planning to try for higher high quality like 4K or 8K video quality encryption. Yes, sir.
Thank you.
Welcome, sir.
Thank you, Tony.
Welcome.
Moving forward, I would like to invite Jagrati Singh to kindly present her paper titled Availability Evaluation in a Thermal Power Plant using Markov Bird Death Approach. Do we have you here with us, Jagrati?
Yes, good morning all.
Yes. I'll stop sharing so that you can present your paper now.
Okay, thank you.
May I request participant to just turn on their video during presentation, if possible?
Okay, sir.
Yes, your screen is visible. You may start.
The video is on.
Yes, the video is also on.
Thank you. I couldn't find my PPT actually.
It's visible on the screen.
My PPT is visible.
Yes.
Okay, thank you. Good morning, everyone. My name is Jagrati Singh Chundawat. I'm a research scholar. I'm pursuing my research under the supervision of Dr. Monica Sani, Department of Mathematics and Statistics, Manipal University, Jaipur. These are the content of my presentation. We will start with introduction, then literature review, nomenclature, system description, assumption, methodology which we have used in this paper, then numerical result, conclusion, and end with the references. So today I will be presenting our study on the optimization, the availability of a thermal power plant, as we all are living in this technology driven world where electricity become the need of the hour, and these thermal plants are used to these thermal plants are oldest source of the generating electricity worldwide. It acts as the backbone of the various industrial, residential, and commercial sector by providing them with electricity for manufacturing, transporting, communication, and lighting, etc. A thermal power plant is a complex system consisting so many subsystems like boiler, coal handling unit, superheater, reheater, condenser, etc. For the better production of the electricity, it is must that all component of this thermal power plants are work without any failure and continuously. These are some literature review related to my study. Kumar et al. Derived a stochastic model in steam turbine power plant for generator using cold standby unit. Bala K 2024 analyzed the availability of a steam generator in thermal power plant and optimized it by using Markov-Bardet process. Again, Kumar et al. 2024 identified the boiler tube failure and economizer failure and examined low availability in the thermal power plants. Salavu et al. 2023 highlighted the crucial component and focused on monitoring these of a boiler plant. These are some more literature review regarding my study. According this literature review, we have observed that primarily studies only focus on the subsystem reliability and the availability, but not focus on the integrating interconnected subsystem. So the aim of our study is to enhance the reliability of a thermal power plant by improving the steady state availability for a interconnected subsystem. These are some nomenclature of our study. Mu I displays the rate of failure rate, and the gamma I represent the repair rate for the subsystem. Capital XYZ represent the system is the full working state, and YI displays the system in a cold standby unit, and small xyz displays the system is the non-working state. This is our system description. Our system contains three subsystems. First is boiler, second is superheater, and third is the reheater. The boiler contained a single unit, and the superheater contains the two units which also connected in the parallel form, and the second unit is in the cold standby unit, and the third is a reheater. All these three units are connected in series configuration for our system working without any failure it is necessary these all unit working. If any one unit is fail among these three, the system will fail automatically. These are the some assumption regarding our study. We assume that all subsystem operate smoothly without any failure, and the component level redundancy redundancy for the cold standby unit. We assume that either all the system in the working mode or either in the fails mode. The repair rates are statistically non-dependent and consistent. The table shows the failure rates and the repair rates for the particular subsystem. These are the methodology we have used in our paper. We have used the Markovian model, Markovian birth date probabilistic approach. In this figure, we can see that the circle shows the component in the working state, and the rectangular shows the component in the failure state. We have 2 working state and 5 failure state. For solving this Markovian birth model, we have used Champagne-Kolmogorov differential equation, which are shown in the next slide. These are the Champagne-Kolmogorov differential equation we have used for solving our mathematical model. For calculating the availability of equation for the model, we have used the initial condition which are shown in the equation number 12. Also, we are taking the normalization condition summation I1 to 7 pi equals to 1, and we derive the availability equation which are shown in the equation number 14. These are some numerical result for our study. We can see the table shows the impact of the variation in the failure rates in the thermal power plant, and we can see the base value. As we are increasing the failure rate, we can easily observe that the availability decreases, and we also make variation with the failure rate with 10%. It's also show that as the failure rate increases, the availability decreases. These are the table shows the impact of the variation in the repair rate, and with the variation of 10%, we can show that as the
This is a
repair rate
7-minute
increases.
reminder.
Okay, thank you. As the repair rate increases, the availability of the system is decreases. These are the sub graphical representation with respect to availability and failure rate. And in the end, we can conclude that it observed that the failure rates and repair rates influence the thermal power plant system. So by using the cold redundancy unit, the working of the system can be improved and the system will be performed more efficiently, and we can minimize the cost and maximize the operation time of the system. These are some references regarding our study. Thank you so much. Yeah, thank you so much.
Thank you, Jagruti. Are there any questions?
Is there any similar study exist, Jagruti?
Yes, sir. Yes, sir.
So have you compared your results with a similar study? How
Yes.
yours is better, or how yours?
Sir, similar studies are exit, but I use the variation of 10% in failure rate and dependent rate. These things are not available in that study. And the second is we have used the cold standby unit in the base paper which I have used or I have reviewed. They don't use the cold standby unit.
Any rationale for choosing 10% increment? Why not 5 and why not 12?
It depends on like arbitrary choosing. We can
Okay.
choose 50% also. We can choose 90% also.
You may try the at least one lesser and one greater and can just look at the effects. Thank you.
Okay, thank you so much.
Thank you, Javiti. Moving forward, I invite Satyendra Gupta to kindly present his paper titled Design and Implementation of Face Image Based Liveness Detection Using Deep Learning.
Hello, good morning, all the panel member. Hope I am audible now.
Yes, you are audible. You may present your screen
I'm
now.
just sharing my PPT.
Yes.
Right. So hope my PPT is visible.
Yes, your PPT is visible. You may start.
Okay. So I'm Satyan Gupta. I'm going to present my paper entitled with Design and Implementation of the Face Image-Based Liveness Detection using Deep Learning Techniques. uh, this is the introduction. So, liveness is a major factor when we are dealing with the biometric attendance or some online platforms like finance and banking sector, because of the KYCs and all the things are happening online nowadays. So, it is a critical component in any online pipeline for KYC or biometric systems. Main challenges are like face spoofing with images and replicating the videos of the same person, or with the mask we can spoof the system. So here solution for this complete spoofing technique could be like identify the genuine irrespective of the fake images or videos. So here our objective is to leverage the deep learning techniques for some robust system to find out these spoof images and videos. Next is this is a problem statement. So main threat for liveness is like growing in the threat spoofing attacks like paper attacks or this video attacks. Second, security risk in the digital identification verification, like KYC and all. And challenge in real-time liveness detection also because of the active liveliness and all. We require user interaction also, but the passive liveness can help us to make it in real time. Uh, the limitation of traditional biometric authentication is also there because earlier we used like optical flow based method or some classical machine learning. Those are not that much effective because of the advancement of the cameras and spoofing techniques. So our goal is to ensure the system distinguishes real and spoof images and videos. So there could be two approach for this solution. So one is like active, where we require user interaction with the system, and one could be the second one is the passive, where we don't require any user interaction with the system. Uh, these are some related work references here. So earlier, like a CNN features structure we used for extracting the feature, and then we give our classical machine learning, or we utilize the optical flow method. After advancement in the CNN, like temporal feature based CNN, 3D CNN, and nowadays LSTM for finding the relation between the data and then propagating through the network. With the advancement of the transformer and all, we have the attention based CNN also that can help us to identify the spoof and real images or video. GAN for generating the spoof sample is the one critical component nowadays, because GAN can generate a very realistic images or videos nowadays. These are the data set we have used. So MSVM FSD is an open source data set that we have used. It is having a studio type of setup. They have created this data set in very wide, in a very like a diverse camera setup, and some wide angle things are also there. And this replay attack mobile is also one a very good data set for spoof and real videos. KCF SD we also used for training purpose and all. So this is also having the same studio setup kinds of data. We have also collected some data set. This custom data set is our data set where we have set up some wild scenario, and we captured more than 100 videos, and then we created different classes of a spoof. These are the details of the data set we have used. So MSUMFSD is having two class, real and fake. So total numbers of videos they are having 110 in real and 313 spoof. A replay attack is having same, the real video are the same, but fake count is like 192 videos is there. KCFSD test set we have used for testing, and total number is 150 and 150 in fake also. Our data set is real. We collected with our volunteers 100 videos, but we have created 600 spoof video with iPhone, Android phone, and some back camera and front camera setup. So next is the data collection and preparation. So we collected the data. We do the face detection. We crop the face, and then we check where all the faces are enough bigger to process. This is the approach we have followed for our deep learning architecture. So for like input layers, we have a rescaling and normalization layer there. We are rescaling the images to 224 by 224, and then we're normalizing between 0 to 1. So we have used convolution, two types of convolutions, one 2D convolution and then separable convolution for efficient feature extraction from the images. And then we use a residual connection to overcome with the gradient descent issues. Best normalization we use after every CNN just to normalize the data, and then to stabilize the learning also. Global average pooling we use in last to get all the information. Then we use dense layer where we classify the real and fake images. So advantages are like no additional hardware required, and utilizing it can be also deployed with the CCTV feeds also. This is the proposed methodology architecture details, where we have this input layer is one, and like a class convolution 2D layer is count is 4. Separable convolution 2D layer we have used 7 numbers, and then best normalization after all the CNN, and we have used activation function, 8 activation function after every convolution layer. Then max pooling, dropout we use for the to overcome the overfitting, and then global average pooling and dense layers. This is the training and evaluation of the model. So we have here this particular model we have trained with MSU MFSD data, and the hyperparameter setup is like learning rate we set 001, batch size we took 32, and epoch we trained with 50. So we have achieved here like ROC we achieved here is 95%.
The 7 minutes reminder.
Hello?
Yeah, 2 minutes.
Okay. So this is again the same network, but we included our own data set in the MSU MFSD, and then we train with the different hyperparameters. So here we like decrease the learning rate, and batch size is the same, but we increase the epochs also. We got some good level of ROC. We achieved 99% on replay attack data set we test that we haven't used in the training. Again, we train the same architecture with slightly different approach. We just changed the epoch to 150, and then we trained the same architecture, and we achieved almost one ROC curve is like 1. The architecture we used in the 3 different model. We trained these all model on CASIA FSD also, where we set up the same scenario like we use for CASIA MSU FSD and our CDAC data. So we train for 50 epoch, but with CASIA FSD, because of the data set is a bit lower quality, the ROC curve is like AUC is having 0.78 only, and with 100 and 150 epoch.
I'm sorry to interrupt, sir. You have crossed the time limit. Can you please
I
conclude
just
the
finish in
presentation?
1 minute only. So the ROC curves are like 96 and 97. These are the evaluation matrix. This is the final evaluated on replay attack and CASIA FSD. These are the statics, and these are the like results are 99% accuracy on replay attack, and 97% on CASIA FSD. These are the key points. like accuracy and loss trend and ROC curves we find on all the data set. These are the conclusions like the to make the system authentication like useful, we can use this alignment model in the pipeline. These are some references for the same that we have followed. Thank you.
Thank you, sir. Are there any questions?
Sir, I think in your own data set compared to some standard data sets, you have a huge imbalance of classes, 600 versus 100.
Actually, it's not an use. Actually, to enhance the feature, we use this kind of subset
Yeah, so
because
my question is how you have handled the class imbalance problem in your proposed approach?
so we do some augmentation on the like a real data set. We extracted the image and we augmented the real data set more in comparison to the fake data set.
And then why you augmented this data? Because you have created your own, right? So you easily create
So
the more
fake,
data
fake
sets.
we haven't augmented because already we have the good amount of fake images. So fake we haven't augmented more, but the real data we augmented because we have the less count of that.
And have you experimented with the different learning size and batch size on the performance?
Batch size we keep constant for the measurement purpose, but learning rate we have set up two learning rate we have set up already.
Is that also?
Yes,
Okay. Thank you, Satyendra sir.
Thank you. Thank you. To all.
Moving forward, I request Meghna to kindly present a paper titled Indian Sign Language to Audio Video Converter for Regional Languages. Do we have you here with us, Meghna?
Yeah, am I audible?
Yes, you are audible.
Okay, I'll share my screen now.
Yes, please.
Is it visible now?
Yes, it's visible.
Okay. Good morning, everyone. I'm Meghna Murthy BV. I'm presenting a research on Indian Sign Language to Audio Video Converter for the regional languages. I'd like to take this opportunity to express my sincere gratitude to the SMARTCOM conference people for providing this platform to share our work. So this project was carried out by our team, Kusuma BS, Preksha R. Sushti MP, and myself under the guidance of Dr. C. Balaringadre sir from Vidyavadika College of Engineering. So this is the flow that I'll be taking. Firstly, I'll discuss on what is the problem that we're trying to solve and objective techniques and the impact. So the problem is communication barriers for the deaf community due to the limited interaction with non-signers in public and social settings, leading to an exclusion and reduced accessibility. Excuse me, I guess I've not turned on the video, right? Is it visible now, my video?
yes, visible.
Yeah. So in India, over 63 million plus individuals have this problem who have hearing disabilities who rely on Indian Sign Language for the communication. So there exists a gap between the hearing community and the people who have normal communication. So to bridge this gap, it is necessary to come up with a real-time conversion system. So our objective is to develop a real-time system that converts the Indian Sign Language gestures into audio and video outputs, enabling the seamless communication and inclusivity. So coming to the techniques, we have utilized the advanced machine learning methods, including convolutional neural network for feature extraction and support vector machines for the accurate gesture classification and real-time processing to ensure low latency responses. So by doing this, we are going to bridge the communication gap, promote accessibility, and enhance the social inclusion for the deaf community in the various environments. So this will be the topics that I'll be covering in the presentation. Firstly, let us know about the introduction, problem, literature review, proposed system, methodology, implementation, result, conclusion, and the future scope. As I mentioned earlier, there are 63 million plus deaf individuals in India who rely on Indian Sign Language for the communication. So various challenges exist in regarding to this topic, that is a limited ISL awareness. Most of the hearing community will not be knowing the basic concept of ISL or any of the sign languages, and this will act as a barrier for the mainstream communication. So the significance lies of the project to bridge the communication gap with accessible ML power systems. So the problem that led us to do this project is that the conversion of Indian Sign Language into audio and video faces several challenges, including the variability of gestures and the requirement for quick real-time processing. So these issues hinder the system's ability to provide the accurate and timely communication for the deaf community, creating the barriers to accessibility. The first most important problem is that ISL gestures vary across regions, cultures, and even individual users, leading to inconsistency in recognition. For example, water in certain part of India will be denoted by placing an index finger on the lip, depicting as a water. In other northern regions of India, we're going to make a C shape using our hand, depicting it's a cup with for drinking water. So there exist various regional variations for this Indian Sign Language, and there is a lack of standardization of Indian Sign Language, which has led to like less number of research done on this part. And the second problem is real-time translation of ISL gestures into audio and video requires fast and accurate processing, but latency can affect the user experience. So some of the wrong beliefs about the Indian Sign Language is that sign language is same all over the world. No, Indian Sign Language and American Sign Language, there are various sign languages, and Indian Sign Languages is not as good. This is also one of the wrong belief. And sign language has been invented by the hearing people to help the deaf people know. It's the deaf people who have found it themselves to communicate with one another. And sign language is not independent on any spoken language. And coming to the literature review, we have also, before developing a system, we done a research on existing approaches. So existing approaches, as then they have used the sensor-based gloves, which is impractical and economical. Also, there are various image-based recognition models, which is compared to our model as less accuracy and not real time. So the challenge is the variability in gestures and regional differences significantly affect the system accuracy, leading to challenges in creating universally adaptable solution for the ISL recognition. So for that purpose, we are integrating the CNN for the feature extraction and SVM for the precise classification and RNN for temporal sequence analysis, enhancing the overall accuracy and supports the real-time functionality in gesture recognition systems. Also, for the future scope, there can be advancement in the real-time systems by integration of AR, VR, open technologies, and the new possibilities for the seamless ISL communication and immersive learning experiences. So our proposed system consists of 4 modules. The gesture detection module, which uses the motion-based segmentation and edge detection techniques, which adapts to environmental conditions like lighting and the background noise. So gesture recognition module, in which screen and extract the spatial features like finger orientation, and SVM, which assigns the label to the gestures recognized. And there's audio video output to display the audio for the corresponding corresponding ISL gesture that has been uploaded, and also it displays the video for the corresponding ISL performed. And the user interface, there is a multilingual and intuitive GUI tailored for the non-ISL users. So this depicts what is the flow of implementation. Firstly, with data collection, ISL gestures are captured under diverse conditions such as varying lighting and backgrounds, ensuring the dataset includes regional and dynamic variations. And next, we have conducted the pre-processing, like input gestures are isolated using thresholding and segmentation techniques. Normalization ensures uniformity across the data samples, improving the model performance. Next, we have done the feature extraction. For that, we have used the media pipe, which detects the 24 hand landmarks, enabling the precise understanding of the hand posture and movement. And a convolutional neural network extracts the spatial and the motion-based feature for the better classification accuracy. And after once that has been gesture has been detected, we have to go for the gesture recognition, in which CNN processes the extract features and classifies the gestures into predefined categories. The model will be trained and labeled on ISL data, achieving the high accuracy in unseen samples. After that, all of this done, the output will be generated in the output audio or video panel. So video outputs with animated gestures enhanced understanding for the non-ISL users. That has been depicted in the form of flowchart that will be starting with our data collection, and we check if the data is valid or not. If it's valid, we're going to continue with the data pre-processing where segmentation and normalization will be happening. Next, we're going to validate the data and extract the features and design and train the model. After that, we're going to evaluate the model, like if it's accurate or not based on the test data. And if it's accurate, we're going to deploy the model in the real-time environment for the output mapping. So this is the result. The system has achieved 92% accuracy for the static gestures for the images uploaded and 87% for the video, like dynamic gestures for the video translation. And the average response time was 0.7 seconds per gesture and the error rate remained below 8%. So I've also included a bar chart which provides a comparison of ISL gestures recognition models across various things. So our model is a combination of CNN and SVM, which has achieved the highest accuracy.
7 minutes reminder.
Yeah, thank you. And compared to other modules, that is a 3D CNN, RNN, or SVM or CNN alone. And the error rate breakdown can also be present here by a pie chart. The background noise, lighting conditions, high-speed motion errors, and gesture similarity all have contributed for the error rate. And in conclusion, our system, our project aims to bridge the communication gap with advanced ML techniques like CNN and SVM, in which we can make our system as scalable and real-time ISL recognition system with a focus on accessibility, and which will revolutionize the communication for the deaf community in diverse settings. So coming to the future scope, we can expand the system to include the regional variations of ISL or also integrate with AR, VR for immersive learning and communication. Also, we can expand our system to train for American Sign Language data set. And also, we can improve the accuracy and speed with the larger data sets and more advanced algorithms. Also, we can develop mobile and wearable device compatibility for enhanced accessibility. So these are some of the references that we've used for our project. Thank you.
Thank you, Meghna. Are there any questions?
Meghna, can you tell me the role of SVM in your combined approach? What is the rationale why you combine SVM with CNN?
So SVM, after once the gesture has been recognized or feature extraction has been done, the gestures will be recognized by the CNN. So in order to label the gestures, we have used the support vector machine for classifying the gestures and labeling them. For that purpose, we have used SVM.
So have you used linear classifier or non-linear kernel in SVM?
It's a linear classifier.
Linear kernel.
Yeah.
Okay. Thank you.
Thank you, Meghna. Next up, I request Bitin Pratihar to kindly present his paper titled Study on the Effects of Memory on Learning in Neural Networks. Do we have you here with us, Bitin?
Yes. Am I audible?
Yes,
Hello?
you're audible. Yes, you're audible.
Okay.
I'll stop sharing.
My screen. I will share my screen.
Yes, the screen is visible. You may start.
Yes. Okay. So good morning, everyone. I am Bitan Pratihar. I'm a research scholar of IIT Kharagpur, and today I'll be presenting on the topic study on the effect of memory on learning in neural networks. So these are the contents of my today's presentation. So we will be discussing regarding memory in human brain. So human brain generally has two types of memory. One is maybe termed as the pulling memory, and another may be termed as the pushing memory. So pulling memory is nothing but a memory that pulls a person towards itself. That means he spent some significant amount of time on memorizing some past incidents, but they do not gain anything significant in their decision making directly. On the other hand, the pushing memory, that is also known as the working memory, this pushes a human being to take various appropriate decisions for various decision making and all those things, and they have a direct influence on learning. So we may say that if it is 100% pulling memory, then the pushing memory does not contribute anything to it. However, if it is 100% pushing memory, it may exert an impulse that may lead to the local minimum problem. So hence a proper combination of pulling and pushing memories may be required to ensure a significant effect on the of memory on the learning of neural networks. So what is the main significance of this present study? It is that we attempted to study the effect of pulling and pushing memory and their combination on the learning capabilities of one of the neural networks. So in this present study, we are using a multi-layered forward neural network. So in this proposed algorithm, we are considering the pulling memory as a source and the pushing memory as its effect. And we are using a simple model, that is the Ohm's law, that is V equals to IR, just to make a relation between this pulling and pushing memory. Now, as we can see, we are considering a multi-layered feed-forward network. And in this present study, we are using there is a single input layer, a single output layer, and we are considering only one hidden layer. So it is basically a shallow network. We are not considering a deep network in this case. Now, one of the methods to train this neural network is using the backpropagation algorithm. Now, steepest descent method generally uses this delta rule to update the weights of the neural network, connecting weights of this neural network, and we are modifying this delta rule using a different relation in which, in addition to this minus eta del D del W, where eta is the learning rate, E is the error, and W is the change of weight, where we are introducing a addition. From the Ohm's law, as we know that V equals to IR, and power can be termed as I square R. So we are introducing this term for modified learning, and also combining the presence of pushing and pulling memory to this learning. So here, and T is nothing but the iteration number. And here the error E is calculated as using this formula, which is basically the squared error, which is the weighted average of the squared error of the target and the target output and the output that we are finding out during learning. So what we are doing in this proposed algorithm, we are using a nature-inspired optimization algorithm. In this case, we are using a bonobo optimizer. So it is a nature-inspired algorithm, which is also a population-based algorithm technique. And however, as compared to other common techniques, population-based optimization techniques such as genetic algorithm, it is intelligent. Means it is intelligent as well as it has some memory. So what we are doing, we are at first fixing the pulling memory value V as that is, the population consists of two terms. One is eta and another is R, where eta is the learning rate and R is the resistance. We are varying it in a range of 0 to 1 and 0 to 2, and we are calculating the pushing memory, that is I, and the power. Now, this is the flow. So at first, we are initializing the population. Then we are calculating the fitness value of each of all the bonobos, which is nothing but the error, considering all the training scenarios L, and considering this at the fitness value of the candidate solution of the bonobo. Next, we are using the modified delta rule that we discussed earlier for updating the connecting weights of the neural network. And we are repeating this step 2 and 3 to determine the optimum value of eta and R. So next, we tested this algorithm on two well-defined data sets. The first data set was the airfoil self-noise data set. And we can see that when P is 0, that means we are not considering the effect of memory, and we are just using the delta rule. So during that time, and when we are optimizing the value of p, or the combination, the effect of memory, and we are getting an optimized value too, we are seeing that we are able to reduce the training as well as the testing error. So we also used another data set, that is the combined cycle power plant data set, and it also showed a similar trend in which during the training of neural network, pushing memory could make significant contribution and make it more efficient in terms of accuracy. We can see that when there is the effect of memory is included, it becomes more accurate for prediction. And however, there increment in the computational cost. So basically what we are trying to conclude in this paper, we are trying to see the effect of memory on the supervised learning of a multi-layered feed-forward neural network using a modified delta rule of backpropagation algorithm. And we can see that memory has a significant contribution in the performance of neural networks using principle of supervised learning. Also, a proper combination of pulling and pushing memory helps during the learning process of neural network. Also, in future, this memory supported reinforced learning based deep neural networks may be developed that will help to solve various real world complex problems like language processing, image processing, and others. These are some of my references. Thank you. I will be happy to take some questions.
Yes, Bidan.
Yes, sir.
Have you just tried as of your presentation for the shallow network, right? So
Yes,
will your
sir.
modified delta rule change if you use a deep network, or is there any effect of this delta rule on the network layers?
Yes, sir. In this case, we are just using a shallow network. So when we will use a deep network, deep learning. So what we can do is, at first we may use some different relation between this pushing and pulling memory. That in this case we are using just a linear relation, that is v equals to ir. So we may modify it even further, and in the same way we can modify all the weights of each hidden networks. So basically we can means explore that thing, that how to use some different relation. Instead of this linear relation, we can use some other non-linear relations to better model these two things.
And the optimization function or the method you use, is it single objective or multi-objective optimization?
It was a single objective optimization.
Do you think that any applications of multi-objective optimization in your case?
Multi-objective may be there, but for example, here we are optimizing basically. No, sir. I think in this case, for neural networks, in this case, we do not require multi-objective.
In case of reinforcement learning, I think you need a multi-objective.
Yes, that yes. We are yet to explore that. So yes, sir. In that we may need it.
Thank you.
Thank you, sir.
Thank you, Bitan, for your presentation. Now I'd like to invite next presenter. Next, we have Martin Molina. He's going to present on the impact of privacy regulations on digital marketing practices, descriptive study. Martin, are you here? Okay, you may please proceed with the presentation.
Martin, you're not audible. Hello? Martin, you're not audible. Do you want to rejoin once? Or connect to audio? Can you please rejoin once? Since there's a technical glitch at your side, Martin, can you rejoin once, or we'll be moving forward and we can take your presentation the next? I have some issue, please wait. We'll be moving forward with the next presentation and you can present after that person. Is that all right? Please message in the comments once. All right. We'll take that presentation the next. We'll move forward with the next presenter for the time being. Like to request Sachi Joshi to kindly present her paper titled The Next Frontier in Cancer Diagnosis, a thorough examination of machine learning and deep learning advancements. Do we have you here with us, Sachi?
Yes. Am I audible?
Yes, you're audible. You may share your screen.
Is my screen visible?
Yes, your screen is visible. You may start presenting.
Uh,
Yes, you may start.
Good morning. Myself, Sachi Joshi. I'm working as an assistant professor at Charusat University. My paper ID is 669. And today I'm going to present on the paper entitled The Next Frontier in the Cancer Diagnosis, a thorough examination of machine learning and deep learning advancement. These are outlined for my presentation. Introduction. As we know that in nowadays cancer is a very complex disease and it is characterized by the uncontrolled growth and spread of abnormal cells, and it can affect almost any tissues and organ of our body. Nowadays we also know that the machine learning and deep learning as a part of AI is a very revolutionary technology to recover this disease. By using advanced machine learning and deep learning technique, we can recover. We cannot directly say that we can recover, but we can detect early detection and improve the treatment of the cancer. The purpose of this review is for early detection. By using advanced machine learning techniques, we can identify a cancer in very early stages and improving treatment outcomes. Limitation of traditional methods. By using a conventional machine learning techniques, we have to do a manual interpretation of the data sets and which can be error prone. By using advanced machine learning techniques, we can provide a higher accuracy. Now integration of AI. AI powered model enable automated detection using medical imaging or histopathology or mammograms or genetic analysis. And we can also personalize medicines. Machine learning algorithm helps in tailoring treatment plans based on the individual genetic and clinical data. The objective of this review is develop a machine learning models which is incorporated with the deep learning model for accurate cancer detection by using to compare a different classifier used in the cancer diagnosis. Here the classifier in terms of a different algorithms and address challenges in a cancer detection across imaging, biomarker analysis and genetic studies. The literature review is given here for the 5 types of cancer. in this literature review, in this review paper, I classified the five types of cancer, which are breast cancer, lung cancer, cervical cancer, leukemia, and brain tumors. Which data set is used for this cancer and how they can identify, which is shown in the literature review, like which type of cancer, which methodology, machine learning or deep learning methodology or combination of both are used in that paper, which data set is used and the evaluation parameters, and by using that algorithm, how much accuracy I identify in this literature review, only accuracy, how much accuracy that algorithm is given is mentioned of breast cancer, lung cancer, cervical cancer, leukemia, and brain tumor. These are the images for that cancers. In this review, the data set is used of medical imaging and genetic data collected from the various cancer studies. Some machine learning methods applying in this review are for feature extractions and multiple techniques like supervised learning, CNN, SVM, random forest, and any hybrid approaches combining deep learning and traditional statistical methods. Accuracy, sensitivity, specificity, and F1 scores are evaluation parameters which are used in that papers. Results and analysis. By using the CNN model, breast cancer, by using a mammography images that give high accuracy. By using a random forest, leukemia, using a blood smear images give the better accuracy. And by using a support vector machine, lung cancer and cervical cancer give the better results. The conclusion after this review is that machine learning and deep learning are nowadays transforming cancer diagnostic by enabling early detection, uh, increase in the terms of accuracy and many parameters, and supporting personalized treatment plans. In the future, we can say that the research should focus on refining AI models and integrating them with the real world healthcare system. These are the selected reference for the paper. Thank you.
Thank you, Sachi. Are there any questions?
Sachi, have you compared your work with any related work in the literature, from the literature?
No, sir. Based on that, I will reach on some conclusion that I supposed to be work on this particular cancer.
And have you tried any parameter tuning while testing your or while doing experimenting with the data sets?
Yes. In the further of after this literature review, uh, I worked on the breast cancer and different parameters, and I compared different parameters and algorithm of the breast cancer.
Okay, thank you.
Thank you, sir.
Thank you, Sachi. Moving forward, I would like to invite Martin Molly to kindly present his paper titled The Impact of Privacy Regulations on Digital Marketing Practices, a Descriptive Study. Do we have you here with us, Martin?
Yes, ma'am. Am I audible?
Yes, now you're audible.
Okay. Thank you so much. I'll be
You may
sharing my
present.
screen now.
Yes, please.
Is my screen visible?
Yes, your screen is visible.
Okay, I'll be presenting on the topic.
Can you please
The-
put it in presentation
impact.
mode?
Sure.
Just press F5.
Okay. The impact of privacy regulation on digital marketing practices, a descriptive study. And I'm from Data Making Institute of Higher Education and Research. My co-authors are Dr. Deepak Sharma, Dr. Pankaj Kumar Anwari, and Mr. Chetan Parikar. So moving to the next slide, these are my table of contents. We have the introduction, methodology, an overview, impact of privacy regulations, challenges, and opportunities. And also we have conclusion and references. So the introduction part talk about how the modern marketing practices have personalized advertising and improved experiences, and with also boosting sales. And also, we can see how the increase of data privacy concern are forcing measures into global regulation standards, including the European General Data Protection Regulations and also California Consumer Privacy Act, CCPA. These laws reinforce individuals' capabilities for managing their data while forcing businesses to take better consent, transparency, and protection measures. So moving on to the next slide, this is the research methodology. This particular research is based on review, and it is secondary research. It carried out a detailed review of academic literatures, industry report, and documents of regulatory bodies to examine the way in which data collection, consent mechanism, and personalization strategies influence marketing practices. So it also enhance the study in seeing the corporate reports and also other case studies as well. The next slide talk about the overview of the most important privacy laws. And number one privacy law is the GDPR, which is General Data Protection Regulation. This is a big law that was enforced by the European Union in 2018. And it have shared the personal data of European folks, and it lets them have more say on how their data is used, gathered, and kept. As well as firms also stay open and honest about how their data, allowing their data to be used with their consent first. And another one is that this rule says it also gives fines if any of the entity go against this particular law, they can pay some fine to the government so that they can stop your disclosing customers' data to another company. So this is the another law that says it is the California law. It was introduced in 2018, 2020. It has provisioned the consumers like having their data deleted as their request, knowing that personal data is being collected and not having their information sold. So this particular law gave the provision to consumers that they can give their consent to the company, telling them that their data should be deleted at any time so that the company cannot sell their information to another entity. And the impact privacy regulation has on digital marketing. Number one is data collection and consent mechanism. The most significant change technology has brought about regarding privacy regulation is their use and the express user consent for collecting personal data. Marketers can no longer assume that their user consent to the techniques of data collection or rely on the implied permission. Instead, they have a devised clear procedure concerning consent that will allow people to make wise decisions. So we have another one, which is changing in targeting personalization. Personalized content to target ads have been two of the most potent kinds of digital marketing. However, regulation of privacy bias the way the advertisers can track people across different sites and services. For example, with the CCPA, consumers can opt out of allowing their data to be sold to third-party companies. So this particular act allow the company to say if they want. So another one is the first-party data and consumer regulation. As a result of this restriction, first-party data information that businesses obtain directly from clientele through their interaction with their websites and apps to customer support channel. Even that third-party data source from various locations is generally considered less reliable. Building trust and transparency. This particular laws build trust with consumers. Consumers can build trust in the company that their data can be preserved without it being sold to third party or any other agency. So another one is shift towards ethical marketing. These particular laws help the marketers to be ethical in handling consumers' data by securing it safely without any other thing being done. So in conclusion, the technology and media sectors have been transformed by new privacy regulations such as GDPR and CCPA, enforcing stricter control over the collection, processing, and use of consumer data. These laws increase the cost of compliance and put most significant limits on data-driven personalization, but also create opportunities for businesses to build more trust-based consumer relationships. Companies are now increasingly leveraging first-party and zero-party data to balance personalization with privacy. So these are the references. Thank you.
Sir, do we have any question for Martin? All right, so there's no question. We'll move forward for the next presentation. Next we have, I'll just say it. Yeah, so next we have Akshay, and he's going to present on topic modeling in Hindi using BERT, LDA, LSA, and NMF approaches. Akshay, you may please proceed with your presentation.
Hello, is my screen visible?
No, it's not yet.
Okay, 1 second, I'll share my screen. Is my screen visible now?
Yes, it is visible now.
Yeah. Hi, good morning. So my name is Akshay from PS University, and I'll be presenting our paper topic modeling in Hindi using BERT, LDA, and NMF approaches. Yeah, so just to give an introduction. So topic modeling is a type of statistical modeling technique that is used to discover topics in bodies of texts. Now, the rate of generation of data in recent times has been exponential, with 90% of the world's data being created in the past 2 years alone. And majorly, this data has been unstructured, which is why topic modeling is a very important phenomena that must be explored. And topic modeling has been extensively seen in languages like Hindi, but has not been seen in languages like Hindi. I mean, it has been extensively seen in languages like English, but not in languages like Hindi and other regional languages, which is why we took upon this problem. Now coming to our approach, initially we pre-processed the data, and how we did this was we tokenized every document in the dataset to extract their root form. Subsequently, we try to identify all the punctuation marks and all the stop words and try to remove this. Now, the reason we did this was because stop words in itself don't have any meaning. They only contribute to adding a structure and syntax to the sentence, which is why we curated a list of 464 stop words and removed them from the body of text. Post this, we considered a few traditional models initially. The first model that we considered was LDA, the latent allocation. So what it is it's basically a probabilistic topic modeling algorithm that uses Bayesian inference. Now we ran this model over a range of number of topics, and we got the highest coherence score of 0.44 corresponding to the number of topics equal to 19. Now, one of the problems that we faced with the LDA was that it was very static, which meant that it only allocated a fixed number of words for each topic and wasn't dynamic in that sense. That is why certain words which probably supposed to be corresponded to another topic actually didn't. Now, the next model that we considered was the LSA. The LSA uses an SVD and applies it on the term document matrix. So all the similar meaning words were grouped together in the new vector space. Just like the LDA, we ran it over a range of number of topics, and we obtained the highest coherence score of 0.38, corresponding to the number of topics equal to 14. Now, although the LDA is faster than the LSA, it was less interpretable. And just like the LDA, the LSA also suffers in the sense that it is static and has to allocate fixed number of words for each topic. Now, what these two approaches do is they just find a cluster of similar words and return them. They don't really give what topic the cluster of words belong to. So for instance, it just says, okay, this cluster of words is topic 0 and this is topic 1, which is what prompted us to create this dictionary approach to actually identify what the topic name was. So initially we prepared a dictionary from our annotated dataset where each topic was associated with all the words that belong to that topic. Once we did that, we ran the LDA model and LSA model, and we obtained a cluster of words. Now, we compared these cluster of words to the dictionary that we prepared earlier, and we tried to see with which topic we had the most number of matching words. Now, we associated the topic to those list of words with which we had the highest matching percentage. Post this, we tried another model called the NMF model. So basically, a TF-IDF matrix is created and is fed to the model. As a result, the document topic matrix obtained is normalized. The NMF actually gave us the highest score of 0.6277 for number of topics equaling 2. But since number of topics is 2, the topics are very broad, and we deemed that this was not useful enough. We get the next highest coherence score of 0.3192 corresponding to the number of topics equaling 8. Post this, we try to consider a very modern approach, that is the BERT topic. So this is a transformer-based modeling approach and extracts dense representations of documents. So it converts documents into embeddings. After this, we apply dimensionality reduction techniques like the PCA on it, and then group similar words into clusters. So we tried 6 different flavors of the bird topic for both unigram as well as bigram. And this is how the results look. Like we can see, the results of all the flavors of the bird topic outperformed all the traditional models like the LDA, LSA, and NMF. So the Hindi sentence similarity as bird flavor of the bird topic performed the best. And it gave a peak coherence of 0.79 for a bigram approach. Now, in conclusion, like we saw, the bird topic outperforms all the traditional models. Now, scores in the range of 0.7 to 0.8 actually indicate clearer topic structures. Very high scores of 0.9 or more may actually suggest overfitting, where the model is actually capturing very specific patterns and doesn't really generalize well. Now, another question that reviewers might have was why we didn't use perplexity as a measure and why we only used coherence. The reason we didn't use perplexity was because it has a tendency to favor models that memorize data, which is nothing but overfitting. And it measures the probability of the next token without really considering the semantic meaning. So because of these reasons, we only opted for coherence score. So yeah, these were all the citations that we referred to. And thank you.
Thank you, Akshay. Are there any questions?
Can we use that, Akshay, can we use attention mechanism to further improve the performance of bot?
Yes, sir, we can use attention. That way we'll have more context. But that is something that is that we should explore in future.
And will it work on the other languages, same architecture or same flow what you suggested for topic modeling for Hindi? Will it work for other languages also?
Yes, sir. So topic modeling has mainly been done only in English and not so much on other regional languages. And in India, as we know, there are so many regional languages, almost a different one in every state. So the same technique can be applied for other regional languages, but the only constraint is that we need good quality data sets.
Yes, yes.
Yeah.
Okay. Thank you.
Thank you.
Thank you, Akshay.
Thank you.
Moving forward, I request Guhan Senthil to kindly present his paper titled Use of NLP in Medical Document Translation for Low Resource Language. Do we have you here with us?
Yes, am I audible?
Yes, you're audible. Can you please
Sure,
share your...
one sec, yeah. I hope my screen is visible to everyone.
Yes, your screen is visible. You may start
Sure.
presenting.
Okay, so I'm Guhan. I'm a student in Vellore Institute of Technology, Chennai, and I'm going to be talking about the use of NLP in medical document translation for low resource language. And in this case, I've specifically focused on Tamil. So some context before I get into the main research work. What is a low resource language? So low resource languages are languages that lack proper structural data, parallel corpus data sets or different types of data sets that are required to build a comprehensive NLP model that modern day requirements meet. So most Asian languages are considered low resource languages. So you consider Indian languages and other Asian languages or low resource languages. This is despite even in current modern days, the growth of this field in the last 1 or 2 years. Despite this, languages such as English, Spanish, and Chinese still have far more resources and far more nuanced data for different types of natural language processing. And this gap is what we identified and were able to build on. So the main objective behind our research was that in many regions of Tamil Nadu, there are access to doctors. However, the people who are accessing these doctors may not know what they're getting prescribed or understand the different terminology that is used in the medical report that they're given. So because of this lack of understanding, because they're unable to understand English, since these reports are mostly given in English, they start to misinterpret what the doctor says, and this can lead to various different issues. They can lead to loss in trust of the medical system, which is in fact not due to the medical system. It's because there's a misunderstanding going on. So my goal was to figure out a way to bridge this gap, to see if it's physically, is practically possible to implement such a system in the current infrastructure. So moving on, we chose transformer-based model for this approach. So the reason why we chose a transformer-based model is there are some references we have looked at as listed here. Taking a look at these references, and also we tried a sequence-to-sequence model, but the final decision was to go for a transformer-based model because of its superior understanding of context further down a sentence. It can retain more context throughout a sentence, and this is required for rich grammatical languages like Tamil, Hindi, Telugu. All of these languages have extremely rich grammar due to the large amount of characters they have. So we ended up with a transformer-based model. We first tried a sequence-to-sequence and also a statistical machine translation. However, the results were subpar. We weren't able to achieve good enough translations in medical terminology, and also normal translations from English to Tamil, which already exist around. We didn't really get that at good efficiency, so we switched to a transformer-based model with attention-based mechanisms. So my entire research is broken down into 4 different parts. The first is data collection, arguably the most important part of this entire thing. Then the basic transform model construction, then training and tweaking the model, and then how do we practically implement this? What practical impact does it have? Is it feasible and stuff, like looking into that. So for data collection, like mentioned before, I believe that there is a lack in good quality resources for regional languages such as Tamil, Telugu, and especially in such nuanced cases such as medical data. So what we did is we took the commonly available data sources like MIDAS, NMT, CENTAM, and all of this for a normal translation. So normal English words to Tamil words, not specifically in anything, normal conversation translation. And then we augmented the data set with more stuff that we extracted actually from a kind of new way of extracting data, and that is from YouTube subtitles. So there are numerous YouTube videos online that have not machine generated subtitles, but handwritten Tamil subtitles along with English subtitles. So these video sources were scraped using either web scraping or the YouTube API. And then we filtered that into our data set, and we removed some of the stuff that doesn't make sense, that is improper translation. However, some things might have slipped through. That's one area of improvement in this research. Then we also applied some data processing techniques for removing unnecessary words and only extracting the medical terms that we require. So this was how we got the hold of all these medical terminologies, since our goal was not just to do a character by character translation. So an example with this would be heartache would be directly translated in many models character by character into Tamil, where it's supposed to be something called Nenjuvali, which is a common colloquial term that people would understand here. So this model targets that kind of data translation rather than opting for a character by character, just transferring the phonetics from one language to another. It opts for a more understanding type of translation. So the transformer model is a typical base transformer model. We have a default attention mechanism, and we also have a multi-head attention mechanism in order to improve performance and also to speed up the processing of the system. So for training, we went for a checkpoint-based system because we want to be able to pause the training in between and check the progress. So there's a checkpoint every 5 epochs. And we also did something that is called teacher force. Basically, we after one epoch is completed, or no, so after one checkpoint is complete, we take the output of the model, we keep that aside, and we force the actual correct representation, the correct translation thing into the model again for the next training sequence. So it forces the model to understand this is the correct answer, this is the correct answer. This was originally not done. We first went for a normal method, and then we figured out that this actually improves the accuracy better. And as stated, there is a self-attention mechanism. The training was done on Google Colab due to its high availability of GPUs and computational power. And the first initial test was done around 10 to 20 epochs. And then once we were okay with that at a certain level, we went for a full-on model training, which was around 80 epochs. That I believe took around 3 to 4 hours to train on Google Colab. I'm not sure about the exact numbers again. And then the final part was deploying the model. So having a model is one thing, but making sure it can run effectively and cheap, because AI is not cheap to run and machine learning is not cheap to run. So how do you run this model cheap? So that was also another part that we wanted to research into. So the hosting strategy we looked at. So you can go for something like AWS or cloud-based hosting, but these are expensive for hosting GPU processing power and stuff like that. So what we decided is we had a Mac M2 Mini, which has an amazing price to performance ratio than any other compute system available commercially currently. And we were able to run the model on that. So it was exported from Google Colab. It was around a 30 GB size for that model, and it was run on this in a Docker container. And we wrapped it with a Flask server, and then we had a mobile app that would perform basic OCR, so you can scan a text document, and it will convert it to text and will send it to the server, which is running our ML model. So the ML model took around 30% CPU utilization with, I believe, 3.5 GB of RAM, 3.5 to 4 GB of RAM. So it was within a reasonable amount, and shows that it is a viable way to implement it in a normal cloud-based infrastructure if you go for a production scale environment. So this is the mobile application. This was just a demo, so it doesn't have proper user interface. This is an example output of what the model is giving. So basically, this was the text that was entered. In this case, it was printed out on a paper and it was scanned. And then this is the translation that it appears in Tamil. So there were some mistakes. We ran around, I believe, 2,000 to 3,000 different types of text without the OCR, just direct text input into the model, and its accuracy was around 95% in terms of translations. There are only 5% of
This
times
is
that
a
it
7 minutes
failed to.
reminder.
Yeah, thank you. There's a 5% time that it failed to translate the document, which is something that we can definitely improve on. And so these are different outputs, so the metrics that we were able to extract. So first is the blue score. So we tried different tokenization strategies initially because we wanted to ensure higher accuracy. So we went for finally a subword based tokenization strategy due to its higher blue score and better accuracy than other things. And as you notice, there is a flaw with the model, and that is the more amount of characters that are input, the much longer it takes to process. And this is not a linear growth, it's an exponential growth. So this is one thing that can be worked on in the future to improve performance. And this is the training and validation loss over different epochs. As you can see with typical transform models, they do a large improvement at the starting and then they slowly fall off. Yes, thank you. Do you guys have any questions?
Have you tried on simple models before transform-based models for this conversion?
Yes, sir. We tried sequence to sequence and sequence to sequence and also statistical machine translation. Both of them, the amount of time that required to train them was much more compared to the transformer-based model. So at the end, we decided that it's not worth spending that amount of time since compute resources is limited for us.
Okay. In the experiment, do you define any strategy for early termination of your training because you are going with some fixed number of epoch? Can we do it early termination?
Yes, sir. That's also possible. That's something we have to look into, like the automated way of terminating the thing once it reaches a certain level of accuracy. Yeah, that's definitely something that we can look into, sir.
Thank you.
Thank you, sir.
Thank you, Guhan. And with that, we are done with the presentations for this session. Thank you to all of our presenters for their insightful contributions. Before we move to our closing remarks, I'd like to invite Dr. Amit Thakur to share his thoughts about today's session. So, what do you?
Okay, so first of all, thank you, SMARTCOM organizing team, for giving me opportunity to listen these wonderful presentations. Really, I enjoyed the session and the work they presented. And the work with different domains with different insights. And yes, I believe that surely this kind of conferences will contribute towards the growth of nation and will in turn provide some sustainable solutions for the community as a whole. So I'm looking for some fruitful, some concrete output. Those ideas can be coming into and societal solutions which can be used by the needy people, because somebody has presented on the work of sign language detection, somebody's working on economics part, somebody's working on some the language part, and these are some pinpoints which need to be addressed. And this kind of conferences are providing such platforms to young mind, and they present their work, and in turn, few ideas from those presentations may turn up as a product in the society. And once again, I thank you organizers for giving me this opportunity for hearing this wonderful presentation. All the participants have presented their work in a wonderful way. So thanks to all those participants, and big congratulations to them also. Thank you once again.
Thank you so much, sir, for the kind words. I hope everyone enjoyed the presentations today. I sincerely thank our authors for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We'll be happy to have you in the 10th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer, and the publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I also thank our session chair, Dr. Amit Thakur, for chairing this session. And here's a small token of appreciation, sir, from the team of SMARTCOM as well as Global Knowledge Research Foundation and partners. Thank you everyone for your valuable presence. I request you all to kindly switch on your cameras for a quick snapshot of the virtual conference. If everyone can please switch on their cameras for a quick snapshot. Yes? Okay. 1, 1, 2, 3. Thank you so much. Have a good day. Thank you, everyone.